So hi class. So today we will start talk about the friction. So for the lecture 2020. So friction basics. I believe a lot of those information already covered in the physics class before. Let's just try to refresh our memory as soon as possible. So friction. So what's a friction? Friction is a force of resistance acting on a body, so which prevents or resist the slipping of the body, so related to a second body. So that's a definition of the friction, okay, which prevents or resists slipping of a body related to a second body. It acts in opposite direction to motion of objects. So in the physics, we learn a very simple case is that for every object we have its self-weight, here is support, and here is a friction, and also here is our pulling force, okay, P. However, in reality, okay, so there will be a little difference. Self-weight still the same, pulling force still the same, friction still same, but however, this force will be a distributed force, okay? So which means the side more closer to our pulling force will have more support, okay? This force is higher on set of motion. Okay. Also, to simplify, here is if we convert the distributed N to a single force, there will be a distance between the center of the object and to the nth action line. We call this distance x. Okay, we will be use this later. So friction. So let's assume we have very wide object. So the object is which means the object only slips. So we have our pulling and friction. It will be keep increase and decrease, okay? On the right side, okay, on the right side means there is no motion. On the left side is no motion. On the right side is motion, okay? And the highest is Fs, and this one is Fk. So the maximum friction occur just before the block begin to move, Fs equals to mu s times by the n. We call the mu s its coefficient of static friction. And once the block moves, Fk drops, becomes Fk, and Fk will be mu k times by n. Okay, we call the mu k is a coefficient of kinetic friction, and the mu s is always larger than mu k. And friction is not always at the max. Okay, that's a tricky part. We need to check it. Which means please do not assume it is. Okay. So well, we have what about the friction on the inclined plate? So we call this theta. And also we call this direction. We are doing the force analysis. We call this direction x, this direction y. And it has force W. This angle will be theta. This one will be n. This one will be mu x times by n. So let's use our equation. Sum of Fy equals to 0, which means n minus W times cosine theta equals to 0. We can get n equals to W times cosine theta. And also if we have sum of Fx equals to 0, we can get W sine theta minus mu s times by n equals to 0. And we can get W sine theta minus mu s times W times cosine theta equals to 0. 0 for our mu s will be W sine theta times over W cosine theta, which will be our tangent theta. Okay. So for the friction analysis, okay, as always, we need to first, we need to draw free body diagram. Okay. And we need to show the friction force acting as the opposite direction of the impeding motion. And then we need to determine the number of unknowns do not assume F equals to mu s times my n. Okay. then we can use the equation of the equilibrium and the friction equations to solve for the unknowns. Okay, let's do some quick quiz. So we have a 100 lap box with a white base, which is put over the force by P. Mu s is 0.4, which force orientation required this force to begin the sliding. The answer should be A, okay, because the PB and the PC will have more pressure on the box, which means with more pressure from box to the ground will be able to provide more friction, okay, which resists the box to move. What about number 2? So the direction of the friction force on the ladder at B, which how will the ladder slip? It will be slip like in this direction, and our friction will be the opposite direction of the movement. So the answer should be just a C. Okay. What about this one? Like I said before, don't always assume friction equals to mu s times by n. Our friction, okay, mu s times by n, which is 0.3, is 3 lap, which means here is our maximum friction. However, if our pulling force is just a 2 lap, and the object is in equilibrium, which means our friction is also be 2. Okay. Number 2 has a little bit difference. So the ladder will be moved in this direction, vertical. Our friction will be opposite, okay, direction, which is upward, vertical. So you may have a question like whether the object will be tipping or slipping first, okay? So that's a question we will need to solve for this lecture. And again, suppose here is the object. We have a force P. We have W. Distance is H. And also we have N. We have F. We call this distance X. Okay, so how many unknowns we have here? We have unknown at P, unknown at N, unknown at F, unknown at X. Okay, we have 4 unknowns. And we have 3 equation of equilibrium. And also we have another friction equation. So we can solve the unknowns by using 3 equation of equilibrium and friction equation. So let's assume, okay, if slipping occur, the F, okay, will be equals to mu s times by n. So we need to solve for P, n, and x. If x is larger than 0 but smaller than 2 over b, for this case, slipping will occur. If not, it tips. So for when the tipping occurs, we'll assume we know the location of N and F. We need to solve when the tipping occurs. The N is definitely here. Okay. We just need to check. Okay, if F is smaller than mu s times by N, and then tipping to occur. If not, it will tip. Okay. So let's see this question. We have object has 250 lap. Coefficient of the static friction between the crate and the floor is 0.4. Determine the maximum force that can be applied without causing the movement of the craters. So we're given W mu s. Okay. We need to find P maximum. We have a node like P, X, N, and F. Okay. Here is a P. Here is the height. Here is W equals to 250. 1.5, 1.5. So first let's assume it slips. Okay. If it slips, F equals to mu s times by N equals to 0.4 times N, which is 100 lap. Here's N, here's F. Sum of lap factors equals 0. You can get P. Net minus 5, F equals to 0. We can get P equals to F. P equals to 0.4 times by N, which is 0.4 times by 250 lap. Sum of the Fy equals to 0. Okay, sum of movement on point O is 0. Get negative 109 times by 4.5. Okay. You can solve the x. It's 1.8. Okay. In this case, okay, it tips. And so, as long as we know the object will tip, we need to solve Pn, Pf, and N. First, we use sum of Fy equals to 0. N minus 250 lap equals to 0. N is 250 lap. need to check, okay, if f is less than mu s times by n, okay, it satisfies our requirement, okay. So the P maximum is 83.3. Okay, that's pretty much for today.